And it's preparing?
Yes, it's live right now. It's live.
All right, great.
Okay.
Guys, we're just letting everything catch up here. Hello, fellow linear algebra fans and geeks. This is going to be a really good session today. I'm going to show you some extra things because let's remember, we're trying to learn linear algebra better by coding it in Python and Numpy and SciPy and all the great visualization modules we have out there in the wild. Today, we're going to focus on Matplotlib and going deeper into looking at equations normal to a vector, planes normal to a vector. Now, first, I want to show you something that will be helpful. I'm trying to be more disciplined about not just moving stuff. Oh, I need to share my screen. Hang on a minute. There we go. Okay, now here, you see me in DAGS Hub. This is, I've become a DAGS Hub fan, and I want to start putting more of my teaching and my work that I'm sharing on LinkedIn and with the integrated machine learning and AI family here on DAGS Hub. Why? Well, I do love GitHub, and I'm still going to use it, but DAGS Hub has a focus on supporting data scientists and machine learning engineers and artificial intelligence people. So when there's needs that we have in a cloud-based GitHub repo system, we're going to get what we need faster through DAGS Hub. And I've become friends with the CEO and founder, Thom Ives, and I've been impressed with how eager they are to support our community. So today, we're going to be going through code that I've already stored here. Oh, there we go. And it's in a linear algebra repository, but I'm going to create several subfolders in that repo. And this is the one we're working on today. Now, I have a local copy of this repo here on my machine. So I'm going to show you where that's at. And let's go here. Let's see. I really just want to do this. There we go. So here I am in my DAGS Hub repos, and I'm in linear algebra, and then in this subdirectory that will get created when you clone this repo on your machine. So this is under my DAGS Hub repos on my Linux machine. And now I'm going to switch my view over to Visual Studio Code, and we'll go through that most of the time from here on out. So, I need to reload this. I apologize. So I had it open a different way. So when I'm on Linux, I go to this level and I just right click to get a context menu, and then I can open that folder directly in VS Code. So that opened on another screen, of course. Now I've got it over here for our view. And I can, this is that directory directly. Now, one thing to be careful about in VS Code, and I'll make this window bigger for you guys, is that you want to open, if you're going to use the terminal inside VS Code, it's best to go right to, and let me show you this again. It's best to go right to the directory you're working from, like this. You can see these match. Why? Because it'll use this as the current working directory. If we'd opened this, which would have been great, I'd have to be really careful about where I store files to and where I load them from so they end up in the right directory. So I've just found it's less painful to go on ahead and do it this way. Okay, now the first thing I want to do is open up our Markdown file. And oh, well, that's regretful. Look, it's not rendering our LaTeX math for us. No problem. if you install a Markdown Preview Enhanced module from your extension options here for VS Code right here, you can get this and you can view it while you're coding it. And so here's our file for our talk today. Now, you've seen this before, but I want to make sure we're not just working in notebooks. So today we're working in VS Code, and we're going to review the Markdown we had before for the equation for a plane. Now, the equation for a plane is usually shown like this right here, with this a1x plus a2y plus a3z equals d. But notice the different forms I've shown it in. We can treat these a's as one a vector that we dot with any x, y, and z. By the way, this is any x, y, and z in 3D space, real 3D space. And so this is the expanded form of vector A, and this is the dot product, and D is just some scalar value. But what we know from all our work is that A is normal to the plane. And again, just like I said, it bears repeating, so you don't get confused. This equation holds for all values of x, y, and z. Well, if we don't know A yet, but we have 3 points in that plane, or we want to define that plane with 3 points, we need at least 3 points to define it. Like you need at least 3 legs to hold a chair up or a stool up or whatever you want to call it. But then if we set some value for D and we've got 3 points, point 1, 2, and 3, which each have an x, y, and z component for each of those 3 points, we can solve for A1, A2, and A3. Now, we haven't gotten to where we've learned how to solve any size square matrix for a set of values here in this vector. This is like what we will end up calling the A matrix, and not to be confused with this A vector. Oh, I made a mistake here. Let's get that back. That's the vector A. But just in general, this would be our A matrix, our X vector, and our B answer vector. And we will learn soon, hopefully, how to solve for this using the principles of inverting a matrix and stuff, but we're going to find some slicker methods to do it numerically. But right now we're going to do it in such a simple way that it's easy to see the answer to what A should be for a given 3 points by inspection. So, but once we get a solution for A, this is, since it's got to be true for all values X, Y, and Z, well, once we have the values of A through A1, A2, and A3, like we said before, we're just going to put in a grid of X, Y points and solve for the Z's based on our value for D and based on our values for A1, A2, A3. Now, note, we could have had a grid of Y and Z values or a grid of X and Z values to solve for Y, to solve for X and to solve for Y. But I just chose, I'm going to generate a grid of X and Y and solve for Z. So let's start with a simple and obvious equation of a plane problem. Here are my 3 points. I've just got one along the x-axis, one along the y-axis for the second point, and one along the z-axis for the third point. And I'm going to solve for A1, A2, and A3, given that D is equal to 1. Now, let's note, when we're doing this equation for a plane, all values in this vector, I'm only doing it, oh, you know what? I made a math mistake here, because this should be okay, this is 3 equations, so each of these ends up being D. I was a little worried. See, when we do the dot product for just 1 point, this represents 1 point, we get 1 value of D. But this is such that when we run these, we're constraining it that they all equal t. So sorry for that. And so this is still true because I've got this 1 point times each of these values for A, and that first one of this row times these points has to equal 1. It's a dot product of this horizontal vector times this vertical vector. And then the same is true for this one, and the same is true for this one. So that's how we get, we can see by inspection that, well, in order for this first result to be true, A1's got to be 1. And for this second result to be true, A2 has to be 1. And for this third result to be true, right here, A3 has to be 1. So that's how we solve for A. And if we, now note we've set this equal to 1 this time, but we're going to do something different here soon, but let's plot this in 3D. So we have this code in the Markdown file, but what I'm going to do is open up our first one, A plane.
Sorry, Dad, I have a question.
Yes.
Okay, must it always be an identity matrix?
No, thank you, Yuko. And in fact, I don't even want us to see it. It is a matrix, but it's just a matrix of points. Each point, excuse me, each row in that matrix was a different point. The only reason I made it the identity matrix was to make it super easy to solve by inspection.
Right. Okay.
Now, in fact, maybe we will probably have time to create. Notice I have 1, 2 Python files. Well, let's do this, Hugo. With what we're going to see, we can create a third file that doesn't use the identity matrix, and I'll show you how.
Right.
All right. Now, right now, you can see I've got these squiggly lines. That means the Python environment I'm in doesn't know about these modules. So I go down here, and I go to the virtual environment, Python virtual environment that I know has those. I wait a little bit, and those go away. Well, now let's step through this code a little bit at a time. First, I do my imports. And when we do 3D plotting, I have to import this axis 3D. Then we need to be able to do plots, but we also need this CM. And CM, if we highlight that, it shows us, I can go get different color maps from this CM module in Matplotlib, and one of the color maps is cool warm. Okay, so now this is peculiar here. In this part, I am literally plotting the normal vector, the A vector. I call this A, B, and C for clarity here. You know what? Just so it's consistent with our Markdown, let's do this. I got to be careful though, so I don't mess this up. Now, why is it only 2-dimensional? It's peculiar to the rules of Matplotlib for what we're doing. I will try to do, I can't explain it super clearly yet, to be honest. So I'll try to do some more research and add it to the Markdown file to make it more clear. I don't want to make the Markdown file completely go away. I just want to see the mini map here. Okay. So let's, that explained this import. And of course, our good old Numpy. We will need that. Now this time, I need to create a figure ahead of time. This is a little more complex. And with figure, I'm going to add a subplot, but this is to inform Matplotlib. I'm only going to do one. Now, if we had multiple, we would change these numbers for each subplot, and those subplots would show up together. But we only have one subplot. And it's handy to get to this axis level when we're doing 3D, especially so that we can define, hey, this subplot is going to be a 3D projection. Now, we're viewing these on computer screens. So it's not literal 3D, it's a projection of 3D. And in fact, the only reason we see 3D is because we have two eyes. But if we covered an eye, we'd always be seeing just 2D projections of 3D things. And we detect it through shading and size as we go off in the distance. Okay, the next thing, and this is super handy. Again, we're using the Numpy module, and we're using mgrid. And this is brilliant, because what I'm doing, I'm going from -2 to 2, and I'm creating 21 points. Why 21? Because I got to include 0. And I want to include 2, too. So it's going, this J is just one of the rules for using mgrid. So you guys can go get more information by looking at the documentation for mgrid in Numpy. But I'm doing this for both.
I was going to ask if it was a complex number.
It's not actually, and that's a good question. That would be a good guess, but in this case, it's just peculiar to the needs of MP grid. But again, we're going from -2 to 2, and we've got it separated by these colons, and so we're going to create 21 points between those two endpoints. So again, please, I should say, refer to Numpy docs. And then now I want to create Z ahead of time. Now we could have used empty, but because we don't have a big array, I just wanted to create Z to be zeros. And so Z is going to be 21 by 21. Why? Because it needs to represent for X and Y. And I'm trying to be good here. This, when we do this, again, these are X and Y, but we need Z values for each X and Y. So that's why we're doing it as a two-dimensional array. It's representing for indices 0, 0, that's one X value. And that's why it's that way. And then notice that we break up the grid. Well, the first part of the grid is of XY is just X, and the second part is Y. So now we have our three components. Again, so we don't spend too much time here, and you can learn things through experimentation. Please check the documentation, but let's do a trick. And I like to do this when I'm learning and I'm studying new code. I'm going to import sys, and then I'm going to put a sys.exit right here because I want to see what's going on in between. And notice how VS Code intelligently grayed out all the code below the sys.exit, because it's like, well, I'm not going to execute that stuff. You're going to exit. But let's do a print. And you know what? Print's not going to be very pretty. I'm going to do a pretty print. Uh-oh, I don't have that yet. Well, let me just show first. I'm going to do this, but now I've got to add pretty print. So I'm going to support pretty print as PP, and then I'm going to define, oh no, forgive me. I don't want to do it quite that way. I'm going to define PP to be equal to pprint.prettyPrinter. Oh, I did that fast. I want y'all to see that. Now VS Code knows I'm interested in using that import from pprint. As soon as I hit that, it's suggesting, well, do you want the pretty printer? Yes, yes, I do. And now, oh, there's Print, well, indent. Yes, I need an indentation for the pretty printing it's going to do, and I only want 2. Now, I've got this pretty printer class instance defined as PP, and then notice that the squiggly lines went away here, and I can see a pretty print of the XY. So let's just run that much. And now you can see what that grid is giving us. So, excuse me. Notice how many levels we have. We have 3 levels here. And the first, you can see that it's going from -2 to 1.8, -1.8, etc., all the way past through 0 and on up to 2. And then here's the next group. It's going to go up, but at a different way. It's running through all of them the other direction. And this is exactly what we needed, a grid of points for X that are 2D and a grid of points for Y. Well, let's move a little further down now. Let's break those 2 apart. So now I've got that highlighted. I'm just holding the Alt key and hitting the down arrow key. And I want y'all to see what we're going to do. We're going to print just X. Then we're going to also, I'm just copying that, and then we're going to print Y. But let's do this. Let's make it more clear. X grid, and want to be constructively lazy, Y grid, and so that I have some distance between these, let's do that. I'm just going to put a new line so they're clearly separated. I'm going to X that out and rerun that. Well, all I've done is broken that grid into 2 grids now, and you can see when we look, we don't have 3 beginning brackets now. We only have 2, but that's because we separated the XY into 2 parts. And so now I've got this one increasing this way, but staying the same all the way down this way. But each of these goes from -2 to 2. And each of these goes, each row is, all the elements of the rows are the same, but they grow. So now I've got this grid of points. And then finally, let's do one last thing. For now, I'm just gonna gray that out, or excuse me, comment that out. By the way, I highlighted that stuff, and then I did Control/ next to your right shift key. Now I want to look at the Z grid. And again, we expect this to be all zeros for now, but we'll just double check that. Oh, did y'all see what I did wrong? This ain't going to give me anything because I grayed that out. I just did Control/ again. Now let's look at the Z, and it's just all zeros, but look, it's in the same format. So these are going to be the Z values, but for those indices of X and Y, that's all we're doing. So these, for the indices of X and Y, these are going to be the X's, the Y's, and that'll make that hopefully make sense of, well, what position is A1 at? These are indices. And well, how do I put this? We'll talk about that more later. Again, I need to get better at explaining that. So now I'm going to gray out or comment out those with my Control/, and then I'm going to highlight that. Now I want to look a little more. I just want to go, well, actually, I think I'll go ahead and comment that out. Oops, comment that out. And now I've got all this code down here active, but what I'm going to first do is not do this plot of the normal vector and not yet do this informational plotting, although I think I do want those limits because that's pretty key. And I want to show you without the aspect too. And we'll go ahead and use this tick params. And let's show that much of the plot. Okay, now I don't have my normal vector plotted, but there's that plane we're plotting. And we needed those grid of points for X, Y, and Z to create that. But once you're here, you can rotate this. Now you can't rotate this in a notebook, unfortunately. So that's why I'm running outside of Notebook. But if you were using Plotly and you did similar routines, you could do it there. So how can we get more information? Well, it'd be really nice if we could see this. And this is the vector normal to that. Well, let's see. Oh, hey, that doesn't look perpendicular to that plane. Well, if you can trust me, these are at this z-axis is at the same scale as X and Y here, but it's not at the same visual scale. In other words, it goes from -2 to 2, but if I were to take a measurement looking straight on at that, well, let's see. There we go. I'm trying to get, like, you can guess what I'm trying to do. And then I took a view of this, of looking straight on at this one, and we measured it on the screen. They're not the same. So that's a problem with, hey, we're using this visualization to help us gain perspective. Well, we need to set the box aspect. And this is forcing those to be scaled visually the same. And I probably could have used, I know X and Y are already going to be the same, but I'm going to do something. I want them all to follow the X scaling. And so I'm going to rerun this now. Ah, great. That does indeed look perpendicular. And you see this is taller now. They look all the same. It looks like the box looks like a cube, like we want it. And if we look at this from different angles now, we can see it's always perpendicular. And that's exactly what we want. And what you're visualizing is more than 2 decades of 3D rendering practice. That's why I'm able to roughly keep that plane, looking like a slice to the screen. But you can do that too with decades of practice or less. Okay, now we've seen enough with this. So just so we can see more of the code at once, I'm going to get rid of it. And so now we're plotting the normal vector to the plane. And we've got the aspect of the plot all equal. We've got the tick marks. Let's give the title back. So I did a control/ there. Let's get labels on the axes. And this should be the whole shebang. So now we'll look at it again. And there's everything, our title, our axes labeled, and our our normal vector to the plane that not only is normal, but actually even looks normal inside Matplotlib. Okay. Well, D is just set equal to 1 here. So what would happen if I did various values of D? Well, let's close this one and open the multiple planes along in the normal. And I'm going to make that same change just to be safe. It renders fine anyway. But now I've just taken some comments out of the previous one. Let's make this change, and I'll make sure I update this in the repo too, and I'll even show y'all how I do that. But now we need to be careful to update this. So this matches our Markdown file. And all this is what I'm doing now is explained in the Markdown file. Oh, I really appreciate those squiggly lines in VS Code. Helps you so much. It also lets you know when you're not using something that's imported. Now, even though this isn't being used, I think we still need it, but for grins, we'll try it without. Now let's look. Remember I had D equals 1, and there's 1, but I'm going to grab multiple values of D out of this tuple, and I'm just going to recalculate Z for all my X's and Y's that I got up here. And then I'm going to create 1, 2, 3, 4, 5 different planes using this over and over. I'm going to use the same color map. Need a little bit more space. Now let's see okay, just to reiterate, this file is exactly the same as the previous one. The only thing that's changed is this became a for loop, and these two statements are inside that for loop. So here it is. That's what it is. The reason it looks a little shorter is the comments are taken out. Oh, would you look at that? Isn't that a thing of beauty? And if we rotate that, you can see, yep. So what we're saying is this is truly amazing. And if we understand it deeply, it's going to matter a lot as we move forward. And let's go back to the Markdown file now.
Sorry, was there any reason why the planes were spaced by the way you spaced them? 0, 1, 0.5, something like that?
Just for fun visualization, because look, Hugo, right?
Okay.
Well, let me turn that off. We don't need that right this minute. And let me go back to here. Even because I decided,
yes.
Yeah, I just decided to space them this way. By the way, we could have used a Numpy A range, where A range will allow you to use float values. So I probably could have gone from 0 to 2.5 and stepped by 0.5. I think A range will do that. We can try it here in a minute because we're going to try some other things. But over here in the Markdown file, I repeated all this, but I just show that here was visualizing one plane in 3D. And then we're going to slide down and do multiple planes in 3D. But like I said, we're just going to leave D as a variable this time. Uh-oh. If we're going to do that, there's something we need to do that I didn't show here. Do y'all see what it was? Just be careful here. When I solve for, this is really the equation. So I would have needed to divide that by A3. So just be careful. In fact, let's copy that and put it down below so it's clear that, hey, so given our values for A is what we really need to say when we see those. We'll say given our values for, and then I need to create a vector, A, given our values for A, this, oh, nope, my bad. But what I just put in the buffer becomes that. So that's what I'm saying. Given our values for A, and B, this equation becomes this. And so now that we know that, all we're doing down here when we do the multiple ones is, we should say that again too, just to be very careful for those that come along and read this. Oh, I have to look at the markdown now again. Oh, I am. Okay. Where do I go? So, oh, it's before the code. Yeah. Guys, I apologize. I think I did that in that section. That's right. I think we're good because of the way I worded it. So that's good. So I'll save that. Now let me show you what I've been doing. Here's the Markdown code. By the way, this is Markdown is shorthand method to do HTML. And so this is actually rendered as HTML, but I can go here and say PDF, and it will create a PDF file. Oh, good, Hitesh. I'm glad you thought so. Now, I want to show that directory again. Oh, it was right here. Good. And the PDF has been updated. So there you go. That very thing we remote for you about. Given our values for vector A and the scalar D, this becomes this. And there we go.
Sorry, that same extension, Markdown extension in VS Code?
Yes. So what you want to do, let's see if I can show it to you real quick. If we go over here to extensions, the installed ones, it would be, we would find the one that has to do with Markdown. And it may be that it's a built-in, I just don't remember. There you go, Markdown Preview. And so what Markdown Preview allows you to do, here, if I click on it, it'll show us more info. Let's expand this. And then it tells you how to use it, and it shows you how to preview it. Now I'm in dark mode, so that's why I'm looking at it dark, but you can look at it in bright mode too. But yeah, let's say I close this, what it does for you, I right click, Markdown Preview Enhanced, and it opens up this other window to show me how it's rendering everything. And you guys can go right to the repo and figure out how to create these, store these images and such. Now, let me show you another cool thing here. Oh, look at this. It knows that in this directory, it's a Git repository. And here's the subdirectory in this Git repository that we've been working in. And it's saying, hey, Tom, you got 4 changes you need to push. Well, we're about to do that. And I'll show you how. But I want to show you some other things first. How did I get these images in my directory, these 2 PNG files? Well, you could do it from code, but let me show you another way. So I've run this. And now the Matplotlib viewer is open. I can just click on this and save it to where I want as any file name I want. So that, in this case, that's how I created these. But you can also do a plot.save and give it a file name and do that right in your code. And I actually encourage you to do that. That's a better way in the long run to do it. So I'm going to close the code windows and just have these 2 open and do this. Now, I see I've got this. So let's see, I'm going to show you, in case you're on Linux. Oh, trying to look for the right one here. Oh, very good. Never mind. I'm here. I'm going to right click. Now I'm doing this in Linux Mint 20 or 20 something. But you could set this up with really good terminal emulators in Windows and get the same functionality that I'm showing you here. But now I've opened this terminal window and I want y'all to be able to see better. So I'm gonna, let's see, view, forget how to zoom in. Oh, yeah, I was doing it right. Oh, I gotta do, there we go. Okay. So I've made this bigger and I'm in this repo. Well, now take notes, git add dot. I use these three commands I'm about to show you at least 90% of the time when I'm working with Git. Yeah, I can fetch and I can branch and merge and rebase and all that, but these three commands I'm going to show you now are the workhorse commands for me. So this means I've just staged everything with this git add dot. That means add everything that's been changed. And now I want you to commit everything, and I'm going to give you a message, and that message is going to be changes made during lecture. And then it's letting me know, oh, you had 4 files changed with 20 insertions and 10 deletions. Well, now I only need, and by the way, it already knows this was cloned from DAGS Hub. You see it's in my DAGS Hub repos in my linear algebra in Python. Now I'm just saying push. I'm not even doing origin master or origin main because, oh, you don't have any branches. Yeah, you're on master or main, whatever it's called, master. There you go. It is master. And now you're just going to push that. Okay, great. Oh, well, I don't mind y'all knowing my username, but you won't be able to see my password, given that I didn't fat finger it, and boom, it's there. And let's do a fun check. I'm going to go ahead and close this terminal. I'm going to slide this guy out of the way, and I'm going to bring my DAGS Hub back over for you guys to look at. Sorry, it's a little small. I guess I can, let's make it a little bigger. Okay, now, if we go and view the PDF, because I need to talk to Dean, it doesn't render the math correctly in their Markdown files here. And I think that GitHub does that. So I'm going to talk to Dean about that. I bet it'll make a change to it as soon as they can. You know, they've got a list of things. Given our values for A and D, this was the latest PDF file we generated from our latest Markdown. So that is awesome. So I'll just go back to the main directory, and over time, we'll have more and more files here, and I'll add the files for Manim, for Visual Python. It makes more sense to run those from your clone of this repo instead of trying to have that code stored in the notebook. That's why I haven't added that Manim code and the Visual Python code to the notebook yet. Okay, let me slide that back out of the way, and I'm going to do some zoom. Some zoom back in so I don't forget to do that later. And here we are. And thank you. It figured out, oh yeah, everything's up to date now in your Git. And I think I'm going to take questions now. All right. I'll check. Please interrupt me. Put a question in the chat, or come off mute and interrupt me. I'm going to just do some closing matters. So, guys, if you can't come to our scheduled time, that's fine. If this is too basic for you, that's fine. Really, right now, we're going slow through the linear algebra. Why? Because we're trying to understand how to understand linear algebra even deeper through visualizations and calculations of linear algebra in Python and its modules. So I would say, if you understand Saul's lectures, well, what's the additional value of this? Knowing how to code that stuff in practical ways and to visualize it. Plus, these visualization techniques, you're going to be able to leverage them and use them for other things. So I just want y'all to appreciate that's the real value here. I will try to also add to the Markdown the links to the, like at this level, the links to the lectures from Saul that are germane to what we're doing here. With that, I'm going to stop sharing and we'll end it. Hugo and Hitesh, any questions?
For me, it's clean. It's very clear. Very beautiful.
Good. Good.
I have one.
I'm sorry, Hitesh, did you say you had a question or what? I
Yeah.
might have missed on. Oh, go ahead, please.
Yeah. So if I remember correctly, the perpendicular to the plane actually identifies a unique plane in 3D. Yeah.
Yes, exactly. Oh, I'm so glad you asked this question, Hitesh. I'm going to reshare my screen. And you're exactly right. So what do you need? You see, we needed these 3 points here to define a plane in 3D. But what did that give us? One normal vector that we solved for. But we could have easily defined the normal vector and set a value for D, and then that would have constrained all points in X, Y, and Z to obey this equation. I should say this equation, Hitesh. Once we set values for A1, A2, and A3, and that is a vector normal to our plane, then we can set any value D and make sure that for any grid of points, we obey this equation that you can define that plane with just a normal vector. So think of it this way, Hitesh. Let me go off share now that we've seen that. And that way I'm a little bigger on the screen. Let me explain. So let's say I've got a plane here. Well, and I'm using gravity. If I hang it, that's one way to support it. And that's the normal vector. And we might even say it's welded on there, okay? And then I can tilt it this way, but I welded it so it's perpendicular in these two, in all directions to this plane. It's, no matter how I look at it, it's perpendicular to that plane. Or I need to support it by 3 points. Well, let's think about it this a minute. If it's in 3D, this vector needs to be defined in 3D. So with A, or with that normal vector, we've also defined how, sorry, I'm having a beautiful thought and it interrupted my speech. In a sense, this is a 3D point because we need 3 components along each of the axes to define this normal vector. So I hope that's insightful. All right, guys, let's end it here. You know, you can always get me on Slack to ask more questions. I hope this was super valuable. I think it probably was. I know it is to me. And again, one thing I want to really emphasize, that way I was showing you, if you're starting with someone else's code, look at it line by line and really do the output at key points to understand what's going on, to help you understand someone else's code better. But especially when you're coding your own code, writing your own code, look at it at several breakpoints along the way to see, okay, am I producing what I need? And then, of course, there's going to be trial and error when you're writing your own code. Like, definitely, when I developed these, there was trial and error. But again, if it's someone else's code, break it out line by line to appreciate what's going on. And hey, this is code. We still got to kind of understand it step by step. So when we didn't write it ourselves and we're leveraging from someone else's code, we want to make sure we're still getting as much learning benefit as possible. So again, like for mgrid in Numpy, that's some stuff you'd like to go look up the documentation for, experiment with it, maybe even a separate file in your own learning directory, as I've encouraged y'all to have your own Hitesh overflow and Yugo overflow, where you've got a directory called Python learning or learning, and then a subdirectory Python, and then under Python, tons of directories that deals with variables, printing, styles, lists, for loops, while loops, and you do different experiments in each of those, classwork, like I've shown y'all in Yugo's Python class. You just keep growing it so that, oh, I wonder if I do this, if that'll work. Let me go test it in some standalone code before I pull it into my bigger code. Okay, so I'll watch for messages on LinkedIn and Slack, and we'll have the next class next week.
All right. Thank you, Dad.
Thanks,
Thank
guys.
you, Dad.
Yeah,
great.
Oh, good. And I'll see y'all in mentoring. Take care.
Bye.